This is Stockholm, Sweden, a beautiful and peaceful city, where the Nobel Prize is awarded every year. As you also know, the Nobel Prize is the highest award of mankind to honor, but contribute greatly in the different areas of outstanding people. Since the first prize was awarded in 1901, only 4 people were honored to receive this prize twice. Linus Carl Pauling, John Bardeen, Frederick Sanger, and finally, the woman who won the Nobel Prize. More surprisingly, she was also the first to win 2 Nobel Prizes in 2 different areas. Physics and chemistry. It was magical. So who is she? Marie Curie, pioneering and sacrificing, a scientific legend. Marie Curie, 1867 to 1934, was an amazing scientist. She's the only person to win 2 Nobel Prizes in physics and chemistry. How cool is that? She was a trailblazer in radioactivity, changing physics, chemistry, medicine, and energy forever. This video shares her amazing journey. From childhood struggles and biases to groundbreaking discoveries in her humanitarian efforts during wartime, this video paints a vivid picture of a remarkable person shaped by courage and struggle. Chapter 1. A challenging childhood, an unending academic aspiration, 1867 to 1891. 1. Polish roots and educational foundation. And Marie Curie, born Maria Salome Skłodowska, or Mania, was born on November 7, 1867, in Warsaw, Poland, which was then part of the Russian Empire. She was the youngest of 5 children, with 3 older sisters and 1 older brother. Her parents, Władysław and Bronisława, were both pioneering educators who, despite facing financial difficulties, ensured that their daughters received an education equal to their sons. From a young age, Marie demonstrated exceptional intelligence, curiosity, and talent, consistently ranking at the top of her class throughout her schooling. She completed her secondary education at the age of 15, graduating as valedictorian. 1.2. Overcoming social and financial barriers. Marie Curie's life was marked by tragedy from an early age. Her mother died of tuberculosis when Marie was just 11 years old. This loss deeply affected her, believed to have contributed to her later atheistic views and lifelong struggle with depression. Despite her academic excellence, Marie Curie's path to higher education was not easy. She and her sister Bronia both yearned to pursue higher education, but the University of Warsaw at that time did not admit women. This forced her to continue her studies at an underground university, where classes were held secretly. To make their dream of studying abroad a reality, Marie made an agreement with her sister to work as a governess and children's tutor for nearly 5 years to pay for Bronia's medical studies in Paris. During this time, Marie tirelessly continued to self-study and read books on physics, chemistry, and mathematics. Social and financial barriers did not deter her. Instead, they forged her strong will and an endless drive for self-education. The hard work she undertook to support her sister not only demonstrated her family devotion, but also proved that her path to science was a constant struggle and sacrifice, not the serendipity of a genius. Her life was a chain of cause and effect, where the difficulties of her childhood shaped her extraordinary character and determination. A turning point in Marie Curie's life finally arrived, when she left Poland for Paris, where she would embark on a new academic journey and meet a person of destiny. Chapter 2. A shared destiny with physics and a fateful encounter at the Sorbonne, 1891 to 1897. The harsh student life in Paris. In November 1891, Marie Curie realized her dream and moved to Paris to study at the prestigious Sorbonne University. She quickly proved herself to be a diligent and talented student, always at the top of her class. With extraordinary effort, she earned her Master's degree in physics in just 2 years and went on to complete her chemistry degree. However, her student life was incredibly impoverished. She often faced health problems due to a lack of proper nutrition, surviving on only bread with butter and tea. This absolute dedication to her studies laid the foundation for her later monumental research, meeting Pierre Curie. During this time, Marie became involved in a research project on the properties of different types of steel and their magnetic characteristics. While searching for a suitable place to conduct her experiments, she was introduced by an acquaintance to the renowned French physicist, Pierre Curie. Science became the bridge that connected to kindred spirits. They shared a common passion for research and a rare intellectual understanding. Their collaborative and romantic relationship was built on the foundation of science. Leading to their marriage in the summer of 1895, they became an extraordinary scientific couple, together making discoveries that shook the scientific world. After marrying Pierre, Marie launched an exciting scientific journey that changed physics and chemistry. Chapter 3: The New Era of Radioactivity. The Discovery and Isolation of Polonium and Radium. 1. The scientific context and the beginning. In the late 19th century was a time of great upheaval in physics. The discovery of X-rays by the German physicist Wilhelm Röntgen and the finding of Becquerel rays emitted by uranium salts by the French physicist Henri Becquerel opened up an entirely new field of research. With her keen intuition, Marie Curie decided to choose uranium rays as the subject of her doctoral dissertation to conduct her research. She used an electrometer that Pierre and his brother had built. This device was incredibly advanced, allowing her to measure weak electrical currents and systematically quantify the intensity of radiation. After just a few days of research, Marie Curie made a groundbreaking discovery. Thorium also emitted the same type of rays as uranium. More importantly, she found that the intensity of the radiation did not depend on the chemical compound she was studying, but only on the amount of uranium or thorium present. This discovery fundamentally changed the understanding of radiation. Instead of being a product of chemical reactions, as was the conventional belief, Marie Curie demonstrated that the ability to radiate was an intrinsic property of the atom itself. This was her most important contribution to physics, a historical shift from the chemistry of molecules to the physics of atoms, paving the way for the entire field of modern nuclear physics. 3. The discovery and isolation of new elements. Based on her theoretical discovery, Marie Curie formulated a simple yet brilliant hypothesis. If a uranium or pitchblende was 4 to 5 times more active than its uranium content alone, then the R must contain a new, unknown element with a significantly higher activity. Convinced by his wife's hypothesis, Pierre Curie temporarily set aside his own research and joined her in this work. They began the painstaking and heavy process of chemical separation, discovery of polonium. By the end of June 1898, they had isolated a substance that was 300 times more radioactive than uranium. They named this new element polonium, in honor of Marie's native Poland. Discovery of radium. Just a few months later, on December 26, 1898, they announced the discovery of another new radioactive element that behaved chemically much like barium and named it radium, derived from the Latin word radius, meaning ray. 4. The arduous isolation process is to provide conclusive proof. They needed to produce and isolate these elements in pure form. This work required processing tons of pitchblende in an old, leaky, unheated shed at Pierre's school. Marie personally took on the heavy chemical separation work, processing 20 kilograms of raw ore at a time, while Pierre handled the measurements. Hands became cracked and scarred, and both of them suffered from constant fatigue. Unaware of the harmful effects of radiation, this hardship was not just a technical detail, but a symbol of the couple's ultimate dedication. After thousands of crystallizations, Marie finally isolated 0.1 gram of almost pure radium chloride in 1902, and pure radium metal in 1910. These seismic discoveries brought Marie Curie global recognition, but also ushered in a period of personal tragedy and challenge, especially after an irreplaceable loss. Chapter 4: Recognition and Loss. 2 prestigious Nobel Prizes, the 1903 Nobel Prize in Physics and the Silent Struggle in 1903. Marie Curie, Pierre Curie, and Henri Becquerel were jointly awarded the Nobel Prize in Physics for their contributions to understanding radiation phenomena. However, this award was met with deep prejudice. Initially, the French Academy of Sciences only nominated Henri Becquerel and Pierre Curie. Marie, as a woman, was excluded from the list. Justice was served thanks to the role of Pierre Curie. He insisted that the research belonged to both of them and demanded that the Nobel Committee consider Marie's contributions. Due to his intervention, Marie was added to the list and became the first a woman in history to receive a Nobel Prize. Her near exclusion from the nomination shows the invisible barriers that female scientists faced at the time, and the importance of recognition from forward-thinking colleagues. 4.2. Personal tragedy and continuity. In 1906, Marie's life was dealt a massive blow when Pierre died in a tragic street accident. The grief of losing her husband and collaborator did not break her. Overcoming the tragedy, Marie bravely took over her husband's position as professor of general physics at the Sorbonne University, becoming the first woman to hold this role and continuing the teaching work he had left behind. 4.3. In 1911, Marie Curie was awarded her second Nobel Prize, this time in chemistry, for her work in isolating radium and polonium. However, this honor came with a personal scandal. Her relationship with the physicist Paul Langevin was made public by the press, and Marie was fiercely attacked. She was labeled a homewrecker and was even wrongly slandered as being Jewish. Many members of the Nobel Committee urged her not to attend the award ceremony. Despite all the pressure, Marie courageously went to Stockholm and accepted her prize. This event shows that even at the peak of success, a woman's reputation could be destroyed by external factors. And her story is not just one of science, but of a continuous struggle against social prejudice. In the next phase of her life, Marie Curie proved that her courage extended beyond the laboratory to the battlefield, as she turned science into a tool to save human lives. Chapter 5. From the laboratory to the battlefield. Humanitarian contributions in World War I. The Petites Curies initiative when World War I broke out. Marie Curie put all of her scientific research on hold to focus on humanitarian goals. She believed that science should serve humanity and decided to apply X-ray technology to medicine to save wounded soldiers. She developed mobile X-ray units housed in trucks, which were affectionately called Petites Curies, Little Curies, by French soldiers. Marie personally launched a fundraising campaign soliciting donations and vehicles to build this fleet. She also established about 200 permanent military X-ray centers on the battlefield. 2. Courage and sacrifice on the front lines. Despite winning a Nobel Prize for her work on X-rays, Marie Curie had no personal medical experience in using them. To serve on the front lines, she taught herself to drive, basic auto mechanics, and even a bit of human anatomy. She and her 17-year-old daughter traveled all over the French battlefields, taking and reading X-ray films for over 1 million wounded soldiers, helping doctors quickly locate shrapnel and injuries. The fact that a scientific genius temporarily paused her groundbreaking research to serve an urgent medical cause proves that she saw science as a tool to save lives. However, despite these great contributions, her humanitarian work was never officially recognized by the French government, possibly due to lingering echoes of her previous personal scandal. After all her achievements and contributions, Marie Curie paid a steep price for her career, but her legacy lives on, transcending both time and death. Chapter 6. The Enduring Legacy and the Death for Science. 1. Health consequences and death. After many years of working with radioactive materials without protection, Marie Curie's health began to deteriorate in the late 1920s. She passed away on July 4, 1934, from aplastic anemia and leukemia, directly caused by prolonged exposure to high-energy radiation during her research. Her death was a heartbreaking tragedy, but also the most eloquent testimony to the ultimate sacrifice of a scientist. The very discoveries that made her famous also took her life, creating a tragic cycle for her existence. 2. A legacy sealed in lead. Marie Curie's body was so heavily contaminated with radiation that after her death, remains had to be placed in a coffin lined with 2.5 millimeters of lead. Even after more than a century, many of her laboratory notebooks and personal belongings remain highly radioactive and are stored in lead-lined boxes at the French National Library. Those who wish to access them must sign a liability waiver and wear protective gear to avoid contact with radium. 226, an isotope with a half-life of approximately 1,600 years. In 1995, Marie Curie was interred in becoming the first woman to be laid to rest in the National Mausoleum for her own achievements. 3. Eternal influence. efforts, Marie Curie refused to patent her discoveries, publishing her method for refining radium for the whole world, believing that science should serve humanity, not personal gain. Her work laid the foundation for modern cancer radiation therapy and nuclear medicine, applications that have saved millions of lives. Furthermore, she also initiated a family tradition of winning the Nobel Prize, with her daughter, Marie Curie, and son-in-law Frederick Marie Curie, receiving the Nobel Prize in Chemistry in 1935 for their work on artificial radioactivity, continuing her legacy. Conclusion: a timeless monument of courage and intellect. Marie Curie's life is a complex and inspiring story. She was a brilliant scientist and a strong woman battling gender bias everywhere. She prioritized humanity over research during war. She sacrificed everything for science, giving her life to make a difference. Marie Curie's legacy shines through her discoveries, dedication, smarts, and compassion for others. She's a true icon, breaking barriers and dedicating her life to helping humanity.